section 4.1, problem number 10. Find h to the nearest tenth. So we're trying to find h over here in this kind of double triangle situation. Finding h is difficult. If we try to start with this little right triangle right here, we're going to run into trouble. We need to start with the triangle on the left. Why? How do I know that? Well, in this triangle over here, this one on the right, we don't know any of the sides. I know this angle is 67. This is a right angle. I could find this other angle by subtracting from 90. I think it would be 21 degrees. But I still don't know any of the sides. I don't know this side. I don't know this side. And of course, I don't know h. That's what I'm trying to find in the end. I don't know any of the sides. So I can't use law of sines. And I also cannot use any kind of right triangle, SOHCAHTOA stuff. Either one, law of sines or SOHCAHTOA, you've got to have one of the sides. And I don't have any of the sides in that triangle on the right. So don't start there. We don't have any sides. Whereas this triangle on the left, I do have one of the sides. It's 193. So that's where we need to start. So I have that side. And I have this angle is 32, but I don't have more information, but I can get it. Here's what I can do. Look at this right here. This is 67 from there to there, isn't it? So then if I do the rest of this, angle B has to be 180 minus 67. Do you see where I'm getting that? 180 degrees minus 67 is 113 degrees. This angle has got to be 113 degrees. Why? Because then those together make 180, don't they? Remember, one side of a straight line. If I think about an axis system, if you go from here all the way to there, that's 180 degrees, right? The top of a straight line is 180 degrees. Right? This angle plus that angle all together makes 180 degrees. This is 90 halfway. It's 180 all the way. So therefore, I know that this little 67 and then whatever B is together make halfway around. They have to make 180. So when I took 180 minus 67, I found that angle B has to be 113 degrees. Okay, great. So now that I have angle B 113 degrees, I can find angle C. Angle C is going to be 1, because every triangle holds 180, doesn't it? And this is the third angle in this triangle. So if you look at these three angles in the triangle on the left, they have to total 180. So if you take 180 minus 32 and minus 113, minus the other two angles, I think you get 35 degrees. So this has got to be 35 degrees. Now the three angles add up to 180. Right? The three angles in any triangle have to be 180. Okay, so I was able to find all the angles in that triangle. Now that's very helpful. Why? Because now, using that information, what I can do is I can do the law of sines. Because remember, you can use law of sines whenever you have sides and angles across from them. So I have got, in specific, I've got this angle and the side across from it, 193. So sine, well here I'll start with the side. It doesn't matter which way really. So 193 over the sine of 35 degrees. This is how the law of sines works, right? It's always a connection between an angle and the side across from it. And you can put either one on the top and the bottom. You can put the sine of the angle on the top and the side on the bottom, or vice versa. It doesn't matter. I just happen to put the side on the top. It'll work either way. So now the other fraction, so I've got these two, right? They're an angle and a side across from it. Now that's going to match up with what other pair? Well, which one do I want to use? Remember, I want to get an angle. I should say, this side right here, because that'll be a side in the triangle on the right. I have to get my hands on a side in the triangle on the right. So therefore, I should use this angle and the side across from it as my other combination. Call this x, I don't know what it is, over the sine of 32. Do you see that? Those have to be equal, right? That's what the law of sines says. In any triangle, doesn't have to be a right triangle, and that one on the left that we're looking at is certainly not a right triangle. You can use the sides and the sine of the angle across from it in an equal ratio. So those have to be equal, don't they? So now I can solve for x. Let's do it. So cross multiply, so 193, sine of 32 has to equal x sine 35 degrees. And now, what do we do to solve for x? Trying to get x alone, divide by the sine of 35. X is alone. X has to equal, so I'm going to take out my calculator now. Make sure you're in degree mode. Check my mode here. Well, I was in radian. Let me go to degree. Okay, so now I'm in degree mode. Taking 193 times the sine of 32 equals divided by the sine of 35. I'm getting 178.3100. So I'm going to use 4 decimal places. Why? They only want tenth in the end, round to the 10th, which is just 1 decimal place. Right, but I'm not at the end yet. Whenever you're still halfway through a problem, use a lot more decimals so that your final answer will be accurate. Okay, so I've got x, and x is this side right here, which is one of the sides in the little right triangle, the triangle on the right, which is a right triangle. So now I can use that to help me get my hands on the h. How can I solve now for h? How's that going to work to help me find h? Well, that's a right triangle, so I can use SOHCAHTOA. Or you could just do law of sines again. It doesn't matter. It could work either way. It doesn't matter at all. I'm just going to do SOHCAHTOA because it is a right triangle. So for right triangles, we can use SOHCAHTOA. So I'm going to take this 67 degrees. This is the opposite side, and the x here is the hypotenuse, isn't it? So the sine is opposite over hypotenuse. Sine of 67 degrees is opposite, which is h, what I'm trying to look for, over the hypotenuse x. So opposite over hypotenuse, right? Opposite over hypotenuse. So the sine of 67 degrees is h, I don't know, that's what I'm looking for, over x. I just found x right here. So plug that in. 178.3100. Okay, now how do I solve that for h? Put this over 1, right? Diagonal, diagonal. So h will equal 178.3100 times the sine of 67 degrees. So let me hit the buttons on my calculator. I'm getting 164.1, rounded to just 1 decimal place, the 10th place. 164.1, 164.1. So the trick on that problem, to find h, we couldn't start with the triangle on the right because we didn't have any of the sides. So we had to start over here with the triangle on the left, and we had to get all the angles. 180 total here, subtract, get that angle, get this angle, and then I had to do law of sines, angle in the side opposite, angle in the side opposite to find this side, x. Then I had a side in the triangle on the right, and then I was in a right triangle, so I didn't have to do law of sines. I could have. It's okay. I just went ahead and did SOHCAHTOA because I'm used to that for that right triangle. SOHCAHTOA is only for a right triangle, and so for the right triangle, I did SOHCAHTOA. Sine of 67 is opposite over hypotenuse. Solve for h, and we got it. That's how that works. Number 11. So I'm trying to find x. This is a similar situation. I cannot start with this triangle up here where my x is. I can't start with that because I don't know any of those sides. You can't do anything with law of sines or SOHCAHTOA if you don't know any sides. That's no good. So I can't start there. So I'm going to start with the triangle down here where I do know one of the sides, the 140. I know the bottom. So I can use that to help me find this side y right there, right? From there to there I can find y. So that's a right triangle. See the right angle here? So I don't have to use law of sines. I could. Law of sines will work in any situation. But I'm going to use SOHCAHTOA because I'm just used to it. You could do law of sines, but I'm just going to use SOHCAHTOA, which is only for right triangles. Right? That's why we're doing law of sines in this section, because sometimes we have triangles that aren't right triangles, like the last problem, and we have to use law of sines. We can't use SOHCAHTOA. But when we can use SOHCAHTOA, I like to, and we can use SOHCAHTOA anytime we have right triangles. So this little triangle over here has got a right angle. It's a right triangle. I'm going to use SOHCAHTOA. So I'm going to say, okay, 15 degrees. This is the opposite, and this side is the adjacent, isn't it? So which trig function is opposite and adjacent? Why am I picking this? Because I want to get y. I want to find y. So that's the opposite. And I've got the adjacent 140. So that's tangent, isn't it? So tangent of 15 degrees is the opposite y over the adjacent. That's opposite. Oops. That's opposite over adjacent. Okay, so now I'm going to solve that for y. Put this over 1, diagonal, cross multiply. 140 tangent 15 degrees is 1 times y. So y equals, so make sure you're in degree mode. Take 140 times tangent 15. I'm getting, my calculator, 37.5128 9. I'm going to use a whole bunch of decimals. Why? Because I'm still in the middle of a problem. You want a lot of decimals while you're still in the middle of the problem, just to make sure your final answer is accurate. Okay, so I've got y. Now, how can I use that to help me find x? Well, there's other ways I could have done this, but let's do this. Let's call this entire, let me get rid of this here. Let's call this entire side here. Get rid of that. Call this entire side from here to here. Let's call that W or Z or whatever. I'll just do W because my Z's look like 2's. So I'll call it W. That whole side is W. And I can do that if I recognize that this whole angle here, so now I'm looking at the entire triangle. The whole angle here, these added up, 24 degrees plus 15 degrees is what, 39 degrees? So this is a 39 degree angle. W is the opposite. It's a big right triangle again, isn't it? It's a big right triangle coming on down here. So opposite over adjacent again. So I can just do tangent, because we still have a right triangle. I don't have to do law of sines. I can just do SOHCAHTOA because it's a big right triangle looking at the whole big thing. Tangent of 39 is opposite W over adjacent 140 again. Opposite over adjacent for the whole thing. And once I find W, I can just subtract y and I'll have x. Let's do it. So I'm going to cross multiply, put this over 1, diagonal. So 140 tangent 39 is 1 times W. W equals, again, make sure you're in degree mode. I'm getting 113.36 9, 8. So that's W. W is the whole length. If I subtract Y, I'll get X. Right? So X must be W, take away Y. So W, which I just got, subtract Y. 37.51289. I'm getting a difference for X of 75. And how far do they want me to round this answer? Just one place, 75.9. It was 8.5, so that rounds to 9, 75.9. So I got it by subtraction at the very end. Took the whole length W, take away the Y, the difference was X. There we go. Number 12. This is not an easy question. So we have 2 fire lookout stations are 25 miles apart, with Station B directly east of Station A. So this is a tricky one here. Both stations spot a fire. The bearing of the fire from Station A is north 35 degrees east. Remember those coordinates we learned earlier in the course? And the bearing of the fire from Station B is north 30 degrees west. How far to the nearest tenth of a mile is the fire from each lookout station? So the hardest part of this problem is the drawing of the picture. That's the part that you really want to practice on your own. I'll draw it for you now, but you might want to stop this video and give yourself a second to try to draw the picture. Even if you don't get it, you'll learn a lot from the effort, rather than just watch me do it. Anyway, I'll dive in now, but if you want to stop the video for a second, it might be good to try it on your own. Okay, so I'm gonna do it. So two lookout stations are 25 miles apart, with Station B directly east. So remember the directions from a compass: north, south, east, west. You can put that right on your notes for the exam. So Station B is directly east. So we got like Station A here, and then B is directly to the east. It's east. Directly is meaning it doesn't go north or south. It's just straight east. B is just straight east. Okay, let's keep going. Both stations spot a fire. The bearing of the fire from A is north. Oh, it's north. So I better put these. I better move these down because I got to go north now. Okay, so let me move them down here. I didn't realize. So B is straight east. So there we go again. So B is straight to the east, and then the fire. Let me underline the words I'm specifically reading right now. The fire, the bearing of the fire from Station A is north 35 east. Okay, so what does that mean? You got to be really clear on the bearings thing. So that means if I put a little axis system right at A, the bearing is north. Remember, this north, south, east, and west. So put it right. Whenever they say bearings at a point, go ahead and make an axis system, a coordinate system, right at that point. And then remember, the north comes first. So north 35 east. That means you go north. You start with north. That's why north comes first. But it's not straight north. It's not straight north. It's 35 to the east of that. So, it's about like that. Well, it's probably more like 40 degrees. So maybe about like that. So this angle here has got to be 35 degrees. Like that. So it's north, but not straight north, 35 to the east, 35 to the right. See how that went towards the east of north? So whenever they give bearing angles, they always come off of north or south, so they always come off the y-axis. That's the opposite of reference angles, which we're used to, that always come off the x-axis. Bearing angles always come off the y-axis. North, 35 east of north. North, but not straight north, 35 to the east of that. Okay, so I'll just put the fire right out here. All we know is when they're spotting the fire, they're seeing the fire. The ranger the lookout station right here at A looks and sees the fire north 35 east. So they're looking in this direction and they're seeing the fire. Now, from B, fire station B is also looking and seeing the fire. The bearing of the fire from B is north 35 west. Let's put a axis system right at B, right here at B. And again, the north, south, east, and west. North, south, east, and west. Now from B, it's north, but not straight north, 30 to the west of north. So that means this angle is 30 degrees because it's 30 to the west, right? This is the west from B's perspective. 30 to the west of north, that's the direction in which they spot the fire. From B, when they look at the fire, they see it. Same fire, there's just one fire burning far off up there. And from station B, they can see it north 30 degrees to the west. So there's the hard part. That's the map we're talking about. We want to use that now to how far, to the nearest tenth of a mile, is the fire from each lookout station. So we got to find this X and this Y, or we can call them A and B maybe. What is A? The distance of the fire from station A, and what is B? The distance of the fire from B. How far is each of them from the lookout station? Oh, I forgot one important fact. The two fire lookout stations are 25 miles apart. So that means down here, okay, this is 25 from here to here. The two lookout stations are 25 miles apart. So now a triangle. I've got one of the sides of the triangle. I don't like the way I make an F5. So I can start to figure things out. So the issue, though, is I've got to get some of the angles inside the triangle. I've got to find, like, this angle. Well, it's 90 minus 35, isn't it? This angle here, let me write it somewhere where we can see it right there. That's got to be 90 degrees minus 35 degrees, which would be 55 degrees. Because together they make 90. Same thing here. We got to find this angle, and that's going to be 90 minus 30, right? Because together these make a right angle. They make 90, so 90 take away 30. That leaves 60. So that angle must be 60. So now if I have 60 degrees and 55 degrees, what's that, 115 degrees? So then I can find this third angle at the top. Every triangle holds 180. 180 minus 115, what's that, 65? Yeah, 65. So this must be 65 degrees. So I found all the angles inside that triangle, that fire triangle. So now I can use that to find A and B. I'm going to use the law of sines. Obviously, we're in the law of sines section, but also because it's not a right triangle. I want to make sure you can recognize this even on the final exam, or if you go forward into, calculus and engineering courses or whatever you're going to do with this stuff, that you'd really recognize when you're supposed to use law of sines. This is not a right triangle. There's not a 90-degree angle anywhere inside this triangle, so I cannot use SOHCAHTOA, right? No SOHCAHTOA, because it's not a right triangle. There's not a 90-degree angle anywhere. You can only use SOHCAHTOA in a right triangle, right? You got to have a hypotenuse, which is the side across from the right angle. There's no right angle here. Can't use SOHCAHTOA. That's why we have the law of sines. So I'm going to use the law of sines inside this triangle. And how does that work? It's all about matching up angles and the sides across from them. This is the only side we have, 25. So for sure, we got to use these two. So I'll go 25 over the sine of 65, right? The side over the angle across from it. That's got to be equal to, pick whatever you want. Let's start with A. A, I'm trying to find the length of A here, how far A is from the fire, over the sine of 60 degrees. And I'll do the same thing for B in a minute. So let me solve that equation now for A. You know what to do? Cross multiply, so 25 times the sine of 60 is A. In fact, actually, let me, trying to make sure I have room in a minute for the other one. Let me bring it down here. So 25 sine of 60 is A sine 65. That makes sense. I just brought it down here. I just cross multiplied. And then how do you finish solving for A there? Trying to get A, divide by the sine of 65. Boom, boom. A is alone. So now we can get our hands on A. A must equal. Let's hit the buttons on the calculator. And when you do, you'll get 22.6. If you make sure you're in degree mode as you crank out those angles, and we get that. Oh, whoops, I'm sorry. We don't get that. We get 23.9. I better get my calculator straight here. 23.9. So that's A, 23.9. Come up here now. Notice they did A second, so 23.9 goes there. And now let's go do B. So for B, same sort of deal. For B, we're going to do these two again because they're the main two. 25 over the sine of 65, that side and angle across from it, equals, and now I'm going to do B. B is this side, how far B is from the fire, and the angle across from B, which is 55. So B over the sine of 55. So cross multiply, and we're going to get 25 sine 55 is B sine 65. And then last step to solve for B, divide by the sine of 65 degrees. Boom. B equal. Make sure you're in degree mode again. Crank that out on your calculator. And I'm getting 22.6 for B. That's how far B is from the fire. So that's a good question, and the hardest part was drawing that picture. Number 13. Trees in a local park are hundreds of feet tall. The height of one of these trees is represented by H in the figure shown. Here's H. This is some tree over here. I'll make it a tree. There we go. There's my best artistic ability. Some kind of tree over there. H. So it says, use the measurements shown to find A. A, where's A? Oh, A is, so we'll start with A. We're trying to find first this A right here. So how can we find side A? Well, looks like for that triangle on the right over here, where A is in that triangle. Oh, I'm gonna. By the way, yeah. Why am I gonna start with that one? Why don't I start with this one over here? Well, because I don't know any of the sides, right? I don't know H, I don't know A, I don't know the bottom, I don't know any sides for that triangle on the left over there. So I cannot start with that triangle. I've got to start where I know a side. I know a side over here on the triangle to the right. So I know that side, okay? So I got to get some angles, therefore. If this right here is 25, these two together are halfway around, aren't they? They're 180 degrees. So this other angle has got to be 180 minus 25. and that's 155 degrees. So this other one's got to be 155 degrees. If you can read that there, it's kind of scribbly. There's not a lot of room. There we go, 155 degrees. And then I can find this angle up here also, because 155 plus 15, right? The two angles we've got make, what is that, 170. And so that leaves 10 degrees, because triangle has to total 180. 10 degrees for that angle at the top. So now we have all three angles in that triangle over there on the right. And so now we can do law of sines. Now, I cannot do SOHCAHTOA in that triangle on the right because it's not a right triangle, is it? No SOHCAHTOA, it's not a right triangle. That's why we have law of sines, to help out when you have a triangle that doesn't have a 90-degree angle. It's not a right triangle. So I've got to use the 575 because that's the only side I have. So for sure I've got to use that and the angle across from that one, which is the 10, isn't it? So the 10... and the 575, so I'll write 575 over the sine of 10 degrees. Got to use those two because I know that side. And then what else am I trying? I'm trying to find A. Trying to find A. Now A is right here. Here, let me clean this up a little bit. All right, so A is right here. A is this side. This is A. That's what I'm trying to find. That's what they're asking me to find in this first part right here. So A, that side, and what's the angle across from him? Across from him is the 15. So A over sine of 15. So there it is. There's my two equal fractions. Cross multiply, diagonal, diagonal. So 575 sine 15 degrees is A. Sine 10 degrees. Diagonal, diagonal. Now to finish solving for A there, to get A alone, divide by the sine of 10 degrees. Boom, that cancels. And now we just hit the buttons on our calculator. This cancels, so A will be this. Hit the buttons on your calculator, which I will do as well. Make sure you're in degree mode. These are all degrees, not radians. I'm getting 857. Now, they only want me to round to the nearest tenth. So that would be 857.0. 857.0. But, you know what? I have another part to go. I got to find H still. And so I'm going to use, for purposes of finding H, I'm going to use more accuracy. 857.0257. It was 569, so I round to 57. I'm going to use that as A, more accuracy for doing the second part when I got to find H. So now to find H, which is this side here, that's part of a right triangle, right? That's a right triangle, so I can just use SOHCAHTOA. I have this angle here, 25 degrees. This is opposite, and A is the hypotenuse, isn't it? So that's what is so using SOHCAHTOA. So for this triangle here, I can just do SOHCAHTOA because it's a right triangle. Don't have to use law of sines, although you could. So I'm just going to do SOHCAHTOA. It's easy. So I'm looking at opposite and hypotenuse. That's sine, isn't it? So the sine of the 25-degree angle is opposite H. Oops, getting a little scribbly there. It's H over the hypotenuse, which is little a, which is 857.0257. Right? That's opposite over hypotenuse there. Okay, let's solve for H. Put this over 1, diagonal, diagonal. So 857.0257 sine 25 degrees. I don't make my fives very nicely. Equals 1 times h. And so that's h. Hit the buttons on your calculator. Make sure you're in radian mode. And I'm getting 362.2. 362.2. We got h. So we did it in stages, and we got h. There it is. Finally, number 14. This is not an easy one. They're talking about a lighthouse. B is 9 miles west of lighthouse A. A boat leaves A and sails 6 miles. At this time, it is sighted from B. If the bearing of the boat from B is north 62 east, how far from B is the boat? Well, here again is my suggestion. We have to draw a picture, and the picture is the hardest part. So I encourage you to stop this video. It'll do you a lot of good. I know you probably don't feel like it, trying to get through everything, but even if you just spend 5 minutes, 4 minutes, maybe 3, just trying your best to draw the picture. Even if you get it all messed up, you'll learn a lot more by having tried and then see what I do than if you just watch what I do. Math is a non-spectator sport. You got to get involved. So you really have to try. You'll learn a lot as you try to draw the picture and think about the words and remember your directions, north, up, south, down, east, and west. So try to draw. So pause the video, try to draw that picture, see what you can do. Okay, I'm going to jump in now. Lighthouse B is 9 miles west of Lighthouse A. Okay, so that means B, let me get rid of that. So B must be over here. Lighthouse B, it wasn't a very nice B. And Lighthouse A is over here, right? Because B is directly to the west, 9 miles west. It doesn't say directly, but it must mean direct because it doesn't say northwest or southwest. It just says west. So that must be straight west 9 miles. B is west of A. A boat leaves A and sails 6 miles. We don't know where. It head off this direction or that direction. We don't know. Whatever. It went somewhere. And after going 6 miles, right, it left A and it sailed for 6 miles in some direction. We have no idea right now. At this time, meaning after it had sailed 6 miles, it is sighted from B. They see it from B. And what's the bearing? If the bearing of the boat from B is north 62 east, the boat must have kind of gone up because when they see the boat later, it's like there, so to speak. Meaning, so I'm going to go from B, right? Whenever they give you bearings, go bearings from B. Draw your axis system right there at B. This is north, south, east, and west from B. And they're saying it's what? North 62 east. So it's north, but not straight north. Maybe it's even more like that. It's north, and this is 62 to the east of north. See what's being said there? North, but not straight north, 62 to the east of north. 62 to the east of north. Let me make it a little better, 62 there. Here's the boat. All right. Now how far? It went 6 miles, but not 6 miles from B. 6 miles from A, right? It started at A and went 6 miles. And then they see it from B. They sight it right? It is sided from B. It didn't leave from B, but it is sided from it. It left from A, but they saw it from B at north 62 east. So there's the situation. The question is, how far from B is the boat? They want this B over here, is what they want. So how are we going to get that? Well, here's our picture. That's the hardest part. So we gotta get this angle, don't we? Got to get some angles inside this triangle. We can get that one, right? Because they make 90 there. So 90 minus 62 is 28 degrees. So this is 28 degrees because those together make 90. So now I have an angle. I have an angle and a side across from it. So that means I can start using law of sines. Whenever you have an angle and a side across from it, you can start using law of sines. Okay, so this is going to be a pretty tricky problem. Basically, we're trying to find B. So right now we've got an angle and the side across from it, which is good. But now we can do law of sines, but we need another side and angle across from it. We'd like to use B because we're trying to find B, but that won't work because we don't know this angle across from B and we don't know B, right? That'd be no good. If I called this, angle A or whatever, if I said, well, B over the sine of angle A there is 6 over the sine of 28 degrees. That's not going to go anywhere. There's two unknowns, right? I can't do that. Do you see the problem with that? I can't use B right now because I don't know B and I don't know the angle across from B, the angle A. I don't know either one of those. So even though I'm trying to get B, I can't go directly after B right now because I have two unknowns. I don't know B and I don't know the angle across from B. I don't know either one. That's not going to work. So instead I have to first find the other angle. So let me get rid of this. So instead, first I'm going to have to deal with these two so I can find this angle. Because I do know this side. I do know that side is 9. So let's do that. So that means 9 over the sine of that angle. Let's call it B for boat, sine of the boat angle. Is that okay? Or I'll just say B for boat up there. It's that angle. Equals, right? The side over the sine of the angle across from it equals, and then we'll use the 6 over the sine of 28 degrees, the angle across from it. Okay, so there we only have one unknown. We can solve for B. Let's cross multiply. We get 9 sine 28 degrees is 6 times the sine of angle B, the boat angle. Solve for B, so first divide by 6. And we get the sine of B equals, so 9 times the sine of 28, make sure you're in degree mode, divided by 6. I'm getting 0.7042. I'll use a bunch of decimals because I'm still in the middle of the problem. 2.1 even. Let me add another one. It's 207, so 2.1. There we go. So now, how do I find B? That's the sine of B. But how do I find angle B? What do you do now to turn that into angle B? How do you get rid of that sine? Can I divide by sine? Is that how I get rid of the sine so the B's alone? No. It's not multiplying, is it? It doesn't mean sine times B. It's a function like f of x, sine of B. So it's a function. How do you get rid of that sine then? Inverse sine, right? Inverse sine, and you got to do it to both sides, and it cancels, and you get B alone. So you take inverse sine of both sides, that cancels out the sine on the right, and you get B alone. So hit sine inverse of your answer, of your 0.70421, and let me move this over so we got a little more room here. I'm getting 44.7655 degrees for B. I'm still using 4 decimals. So that's B. That's that boat angle right there. I've got that one. But remember, this is a very difficult problem. Here's the real trick. Whenever we do sine inverse, like we just did, check other possible angle 180 minus your answer. Remember, there's always another angle that might be possible. Usually not, but maybe. So that's going to be, if I take 180 minus this answer I just got, 44.7655 degrees, I'm going to get 135.234, I'll round to 5 degrees. That's another possibility. I'll say, or B can be either one of those. Remember, whenever you do sine inverse, there's another possible answer. You've got to take 180 minus the answer you got and see what that comes out to be, and ask yourself if that'll work in the triangle. What I mean is, could I put 135 in here? Does that fit? What's the other angle? 28? That's still under 180. So yeah, that's a possibility. Both answers are possibilities. See, that's why we have 2 answer blanks up here. There's 2 possible scenarios going on here. And I think it would be best if I go to a fresh screen and draw out those 2 scenarios so you can see how we finish the problem. I'll basically take this and redraw it in 2 separate looks so it makes sense what you're seeing. Okay, here we go. I've drawn out the 2 different scenarios we're talking about. See how they both have the same, they both have the 9 down here, the 6 on the right. See how we have the 9, the 6, the 6. It's all the same angles, right? 6228, 6228, just like in the original 6228. It's all the same, but we have 2 different B angles. Either angle B is a really wide open angle, 135 degrees, or angle B is a really smaller angle, 44, because all they said is from point A over here, the boat traveled 6 miles. We don't know if it went 6 miles towards B or 6 miles away from B. It went north, but we don't know if it went northeast or northwest, and that's why we end up with the 2 different scenarios. In both cases, it traveled 6 miles from A, and when viewed from B is, 62, north, 62 east when you see the boat. So that's 2 very different positions for the boat. And what do they want from us in this problem? They want us to find B here, the boat distance. I'm calling a couple things B, whatever. I think you know what I'm talking about. That B is going to be how far from B to the boat. That's what they're asking. How far from B to the boat? So it could be really small or really big. So how are we going to get it? Well, what we basically have to do now is we have to find the 3rd angle right there by subtracting from 180, don't we? So let me get rid of these extra marks. So if I take 180, because every triangle holds 180, minus 28 and minus 135.2345 degrees, I'll get angle A there. And so angle A, let's do that one. If I do that one, I'm getting 16.7655 degrees for angle A there. And over here, angle A is going to be bigger. It's going to be, again, 180 minus 28 minus 44.7655 degrees. So angle A will be, let's see, 180 minus 28 minus 44.7655. Angle A has to be 107.2345 degrees. So there's two possible angle A's here that are different depending on the angle B, and now we can use that to help us find finally side B. We want to find side B here. How do we do it? Well, these two are across from each other, right? So I can say side B over the sine of that angle, 16.7655 degrees, has got to equal, and I can do the 28 and the 6, they're across from each other. 6 over the sine of 28 degrees. Over here, I can do the same kind of thing. I could do B across from angle A, so that's B, which I'm looking for, over the sine of angle A. In this case, angle A is 107.2345 degrees. Equals, and I can use these guys, which are across from each other, the 6 over the sine of 28 degrees. Okay, let's take both those and go diagonal, diagonal. So we get B sine 28 degrees is 6 sine 16.7655 degrees. Over here, diagonal, diagonal. B sine 28 degrees is 6 sine 107.2345 degrees. Last step to solve for B. Divide by the sine of 28 degrees. Cancels out. B will equal. So let's try that one. So 6 sine 16.7655 divided by, make sure you're in degree mode, sine of 28, I'm getting 3.7. And the other one, divide by the sine of 28 degrees, cancels out, B equals, hit the buttons. Make sure you're in degree mode. I'm getting 12.2. There's the two answers that are possible for B. B could be a big 12.2 or B could be a tinier 3.7. That's how far the boat is from point B. It's pretty close if the boat went left, west and north 6 miles, but if the boat went east and north 6 miles, then B is far away from the boat now. Two possible answers. Make sure when you enter them, you put the bigger one first. See what they said? They said descending order. Descending, like a staircase goes down, descends, goes down. So they want the bigger one first, the 12.2, and then the smaller one. That's descending order, bigger to smaller. There we go. That's a very challenging problem.